Wisk has in excess of 1,600 total test flights across 5 generations of aircraft. So that's a huge amount of experience around our systems, our batteries, propellers, motors, how we communicate, all of those really important aspects of our aircraft. We're now developing preparing for the certification of our Generation 6 aircraft, the aircraft that will come to market this decade.
The New Zealand Tech Podcast, brought to you by Gorilla Technology, proactive and strategic IT.
Greetings and welcome along to the New Zealand Tech Podcast. I'm your host, Paul Spain, and today I am back in Christchurch. I was here last week for the Canterbury Tech Summit. I'm back again for the Innovation Expo and the New Zealand Aerospace Summit.
Well, and thank you to our show partners, Gorilla Technology, HP, Spark, 2 Degrees, and 1NZ.
Now I have the privilege of sitting down for a chat with Catherine McGowan, the Asia Pacific Regional Director at Wisk. And what Wisk are all about is autonomous electric air taxis, and they have been incredibly innovative with their designs and their technologies, and certainly have got at least one world first in terms of the technology that they've been building. So we're going to delve in and chat with Catherine about that in a moment. A little bit of background on their 6th generation aircraft, currently in testing, electric vertical takeoff and landing craft in New Zealand, in the South Island. I've spoken to people that have seen them flying around, and these aircraft, autonomous aircraft, have a range in the direction of 140 kilometres, including reserves. So that opens them up for probably a whole range of possibilities in terms of connecting Kiwis and visitors to New Zealand, to tourist destinations, airport connections, and the like in the future. Previously, there has been a memorandum of understanding between Air New Zealand and Wisk. So there's all sorts of possibilities on how Wisk's technology could be utilised in New Zealand in the future, on top of the R&D type work that Wisk have been doing in New Zealand. And real privilege to delve in with Catherine McGowan and hear a little bit more around what Wisk are up to. So let's jump in with Catherine McGowan. Catherine, welcome to the show.
Thank you very much, Paul.
Maybe a little bit of background for listeners on Wisk. What is it that you do?
What is it that we do? So Wisk has been around since around 2011, and we are developing an all-electric vertical takeoff and landing autonomous aircraft. It'll carry 4 passengers, and it'll operate in and around cities, helping people connect to their destinations in a way that's sustainable and accessible.
Yeah, it's been a really interesting journey, and we've been following some of it on the New Zealand Tech Podcast over the last few years, because there is a unique reality that Wisk has done a lot here in New Zealand. So maybe before we delve into that, you can just talk a little bit about the history of where Wisk where Wisk came from. And kind of where you are in the journey to us all being able to jump in an autonomous air taxi and get flown to work, or whatever that scenario might look like.
It is really neat that New Zealand is part of this story for Wisk. So Wisk is a California company. And when they were developing their Generation 5 aircraft and looking for somewhere to conduct test flying and advance the testing on the various systems, New Zealand came to Wisk's attention because of our regulatory environment and the opportunity to test innovative aerospace technologies in New Zealand under the civil aviation regulations, which allowed for a very careful, very safe way of testing technologies that weren't yet certified and therefore didn't fit within any of the existing rule sets. So that's when Wisk first came out to New Zealand. Yep. And from October 2017 until early 2021, we actually flew our Generation 5 aircraft at a test facility in Tekapo, which was a really wonderful sight. Our American team loved coming out to visit.
How could you not love spending time in Tekapo? I mean, it's such an incredible part of
the world, an incredible part of New Zealand, and to be flying there, just breathtaking, right?
It is beautiful. There are some amazing photographs of the aircraft, just hovering in the air with the snow-capped mountains behind them. So just really iconic. So that's a really cool part of our history. And now we are still operating in New Zealand, and we're working with the regulator and with Airways to look at how uncrewed autonomous aircraft can in the future integrate into our airspace alongside crewed aircraft in a way that's safe and, that supports the benefits our communities are looking for.
So what's your role? Where do you fit in? Because there's a bit of a team here in New Zealand, isn't there? And you've been involved for how many years?
So I joined the Wisk team in December 2021. So I'm coming up 2 years with Wisk. I've got a couple of roles. So I look after our activities in Asia Pacific. What that looks like is we are engaged in New Zealand and also increasingly so in Australia, because the regulators have this approach that we can work with them to figure out how we'll integrate technology. So, coming up with operational validation, with sandboxes, with ways to develop new concepts. We're also engaging up in Asia. As you can imagine, air taxis, there's a lot of cities and a lot of countries looking at this technology and thinking about, as they design the next 50 years of investment in their cities' infrastructure, how can they use these technologies to sit alongside other transport infrastructure and create this sort of integrated and sustainable network. So we have a lot of conversations around the region like that. I'm also helping develop our operational capability for the future. So as you can imagine, it's not just about the aircraft. We have this amazing aircraft with all this technology, but we also in the future will see different types of operations. We'll need different types of qualified people. So there's new career options out there. The way that we'll operate these aircraft out of vertiports, the way that we'll schedule them will vary from how aircraft are operated today. And so we're developing those processes, which is really exciting.
Yeah, I think it's quite fascinating trying to get your head around how cities might be with autonomous air taxis as part of the mix. I still remember a video that Uber put out, which I was never quite sure with what they were doing with their thing, Uber Elevate, whether that was just complete PR spin or whether they were sort of seriously invested into launching autonomous air taxis. And, of course, that they've sold that off since. But the video sort of, catch the elevator up to the top of a tall building and in flies an autonomous air taxi and you jump in and away you go. Kind of looked fun. Is that the sort of picture that we might look forward to? And what's the importance of being able to fly to the sort of top of buildings rather than other sorts of approaches?
That's a great question. So what we're seeing is that cities are thinking deeply about the way that integrated transport systems going to work in the future. Most cities have a growing population. They have an increasing driver for sustainable transport options. At the same time, the ground transport fleet is also electrifying. And so we're having conversations around what are the particular routes within a city, perhaps it's between the airport and a city or an offshore island, a route that has a lot of congestion or perhaps, gets across some tricky geography. We're using advanced air mobility to complement mass transit, micromobility, active mobility. It makes sense for a city. And then the city can think about, what is the infrastructure investment? Where will these vertiports go? How will it work in with the electrification of the grid? Often cities at the same time are looking at making their grid more green. So, it's about us bringing forward those technologies, but having the conversation with the cities to see what matters to them and how can this be part of that future, to help our cities be more livable, to create sustainable, accessible journeys.
Yeah, and I mean, looking at New Zealand, I'm curious, if you have in mind any thoughts on, how autonomous air taxis might apply. I mean, I'm just sort of thinking here, we're sitting in, Christchurch CBD. If you wanted to get, say, to Akaroa, it's a bit of a journey to get across there. Or if you're in Auckland, you talked about flying to islands, to Waiheke, things like that could be a possibility. But what do you see as sort of the realities of where probably the most important journeys might be?
Yeah, I think you've hit it on the head. Those sort of city to key tourist points to airports, perhaps from Auckland to North Shore or out to Waiheke, Christchurch to Akaroa. There are a lot of spots around New Zealand that you can imagine benefiting from this type of transport. The other advantage the conversations we see in New Zealand are around that ecosystem approach to the regulatory change, to the safety conversations, to the infrastructure conversations that will be necessary to enable that future. So you see, great projects from Air New Zealand, you see initiatives from CA, we're working with Airways, there's a number of other aerospace companies operating in New Zealand who are all considering different parts of this challenge. And so when you start to see this connected community that are working together to say, how can we create this future, that's when you start to get those system effects. So I think, New Zealand has some spaces where advanced air mobility would be powerful and would be useful, but it also has this wonderful, this small but, powerful and connected community that are really thinking on, how do we approach that with safety in mind? What does that mean for equitable access for our communities? How does this support our sustainability goals as a nation, which is just so exciting.
Now, I guess in one way I look at New Zealand and it's like, look, we want to attract investment and, testing of all the latest technologies, and for varying reasons, New Zealand has been a great place to test, technology. It seems certainly when it comes to the aerospace sector, there's been a lot of pluses, not an over encumbrance with red tape, but still with safety, being catered to appropriately. But when you look around the world, there's places with much bigger populations. So I guess I'm kind of curious where you see New Zealand's sort of role being, and how commercial would New Zealand be as sort of a market for some of these sorts of technologies compared to much more populous places where it's probably you can imagine there's a lot more money floating around and a lot more people. We don't have a stack of billionaires here and so on, and not saying that this type of technology is something that is going to be exclusive to billionaires, because my understanding is that the technology is a bit more accessible than, say, traditional helicopter, journeys and so on, right?
Yeah, so I guess no one would ever argue that we're the largest market in the world. From the Wisk perspective, I think the real advantage we have is, we're a US-based company based out of California, and so we have, access to that larger market, to that critical mass, but connecting it with New Zealand and, Australia and other countries where we can solve bits of the puzzle, where we can, address parts of the challenge. And what we'll see over time is that, these technologies will seek out larger markets, but at the same time, the technologies that are developed that start to become part of the aviation system, part of other aircraft systems, help contribute to the goals that we might have in relation to search and rescue capabilities and fire, and just enabling the aviation sector to meet some of those other government goals. So it won't all, for Wisk, we are targeting that air taxi market. We do see opportunities there, but there are wider benefits as well for how the aviation sector serves our communities.
And when you look at this, a bunch of companies that are trying to do somewhat similar things, probably each has its own viewpoint on what the sort of the destination is and the commercial sort of aspects. Where do you see that sort of Wisk has done really well so far?
Yeah, so a couple of things for Wisk. First is our autonomous first strategy. So when we come to market with our Generation 6 aircraft this decade, it will be self-flying. We won't have a pilot on board, and that's different to many other in the market who have chosen to go first with a pilot.
Yes.
We do see that the market is heading towards autonomy, and we think it's important to focus on that initially, to build our systems to target autonomy in a safe way, to do the regulatory work, to bring that to the market. And we can see that in the future that creates an efficiency of scale. It makes the technology more accessible in terms of cost, and also as we see more of this type of activity, it makes it safer in terms of it allows us to provide predictability and consistency across our fleet. Something else that's different for Wisk is that we are backed by the Boeing company. So we are working with a strategic and investment partner that's aware of the technical challenge, the regulatory challenge, what it will take to bring to market. And so, we very much tackle these challenges together so that we can, work alongside regulators and with their timeframes, with their expectations, meet all the requirements of safety, our community expectations. So it really it gives us that opportunity to address the autonomy challenge and bring that to life.
Now, the autonomy side is, it's a big interest of mine, generally, whether it's on the roads or in the sky. How hard do you think, the autonomy problems are that Wisk is working on, say, compared to working on autonomous cars and so on? Because it's a very different sort of challenge, isn't it?
Yeah, it is a different challenge, and it's one that we are solving in a different way. So, as you can imagine, there are less scenarios in the air than on the ground. There's certain things like, a zebra walking across the road that you're just never going to have happen in the air.
You hope not.
You'd hope not, right? The other thing that's really important for autonomy in aerospace is that it's certifiable. So, in order to create autonomy that the Federal Aviation Authority and other regulators can certify as safe and can provide that guarantee to the travelling public, it's really important that the aircraft and the autonomy behaviour is predictable, or what we call deterministic. So the aircraft has what we might call a behaviour tree, where we know under a certain circumstance the way the aircraft is going to behave. And so what that looks like is there's actually a high degree of autonomy already in passenger aviation. Around 93% of functions in your commercial airline are autonomous. And so we work with those technologies and we add a couple more that are necessary when you take the pilot out, and so that we can work with the regulator and show that this autonomy is safe, that it's predictable, that we know how it's going to behave, and that other airspace users, piloted aircraft, can see these aircraft as a predictable and safe part of the aviation system.
And I guess we look at aircraft; they're already, a lot safer than traditional passenger vehicles anyway, right? So there's kind of a high bar to meet when it comes to doing any sort of flying vehicle.
Absolutely. And so at Wisk, it's our goal to meet or exceed the safety standards of commercial passenger aviation. So it's really important that as we enter into the aviation environment, we are making it safer. We are contributing to better situational awareness, better safety standards, and so we'll be, as I just said, meeting or exceeding the safety standards, and we're working closely with regulators to do that.
And you talked about different companies that are taking different approaches. That certainly the autonomy is a big focus for you. So could we delve a little bit into how the autonomy works? What are the challenges? What's the technology involved? What's the role of people in the mix? We know, for instance, with Waymo, with their autonomous vehicles, when they get stuck, there's somebody that can help. So it's not just all on the technology. So how does it work in the sky for Wisk?
Yeah, that's a great question. So people will always be part of our system. They just have a different role. So what we have is the aircraft is self-flying, but on the ground we have a multi-vehicle supervisor. So this is someone in our ground station who is monitoring the aircraft at all times. Before a flight, they ensure that it's ready, that it has all its clearances, the aircraft is safe, fully charged, all of those things. And then during the
fully
flight...
charged bit's probably quite important.
It's very important, right? We track that very closely. And so then when the aircraft aircraft is in flight, we're obviously monitoring it for what we call conformance. Is it flying the exact route that we have told it to fly? Is it, flying the navigation precision, communicating, all of those things? And as the aircraft, it will usually be flying in controlled airspace. The multi-vehicle supervisor can also receive any updated instructions from air traffic control or communicate with air traffic control if anything changes. So you can kind of think of them as a little bit like a cross between an air traffic control or a flight dispatcher, someone who is, always aware of what the aircraft is doing and able to just act as that key point if anything should change. We also have, we'll have passengers on board. They are able to communicate with ground staff as well. So we have hospitality managers who will make sure our passengers are safely loaded onto the aircraft, deal with any accessibility issues. We have a safety briefing. And then in flight, in the extremely unlikely event that something should happen or the passengers feel a need to speak, they'll be able to speak with the hospitality team on the ground, which is really great. We also have, you'd be familiar with maintenance staff that you have on the ground for normal aircraft. Similarly, there'll be teams who look after charging the aircraft, making sure that it's serviceable and ready to go. And it's really exciting when we look across these new roles that will exist in the industry, and we're hoping they will open up aviation to people who might not have been able to be part of the sector before. We'll be looking at different skills for maintainers, for our MVSORs and others. So that's really exciting. Another aspect is a couple of technologies for the aircraft. So one is something we call detect and avoid. So a principle of flight at the moment is see and avoid, where the pilot is responsible for always, looking out the windscreen and pretty important. If you see another aircraft that, perhaps air traffic control haven't identified, pilot needs to always be aware of that and take action. So that's an important safety principle that has to be reflected in autonomous aircraft as well. So we talk about a technology called detect and avoid. So in most cases, the presence of other aircraft in the airspace near the Wisk aircraft will be communicated by air traffic control and will be well separated. But in case of a rare incident where there might be something in the air that air traffic control is unaware of or hasn't been seen, the Wisk aircraft will have sensors. So we'll be able to see, perhaps an aircraft that's not transmitting, and if it hasn't received any instructions, it will be able to deviate and take evasive action to move around that other aircraft. So that's one of the, additional technologies that ensures that we are meeting all of those layers of safety, from the strategic deconfliction through air traffic control and other information providers right down to, if something should happen, the aircraft is able to safely take whatever action is appropriate to keep the passengers safe and other airspace users safe as well.
Oh, that's reassuring. Now, there's, I guess, an increasing level of communication also coming from aircraft, isn't there? I mean, you can track on apps like Flight Aware and so on and see what's flying where, altitude, speed, and so on, which is really cool that happens today. That would be part of the data set that you'd be contributing to and tapping into as well for Wisk?
Yes. So one of the really interesting conversations we're having across industry is that information architecture and ensuring that, everyone has access to validated information about terrain, weather, what we call NOTAMs, which are notices to airmen about activity happening in the airspace around you, and then as well that traffic information about other aircraft and about Wisk aircraft is conveyed through the air traffic control system or other companies that are supporting that information flow. So the other airspace users know where Wisk aircraft are, and they and Wisk aircraft are aware of others as well. We talk about electronic conspicuity. So, the idea that whether through ADS-B or other technologies, aircraft are all contributing to situational awareness as a way to make the airspace system more safe.
And is there a range of sort of other sensors and so on in terms of, there's temperature, there's, a whole lot of kind of, things that sort of, matter in the sky, some just from a, understanding what's happening with weather perspectives, that might impact sort of, future flight. There must be a whole lot of data sources and so on that you would bring in, and all of those things contribute together to, make a decision on even whether it's safe to fly in the first place, as well as collecting the data on the go if I don't know, a storm sort of springs up or something, right? A tornado, for instance.
Hopefully not in New Zealand.
Hopefully
not. Yes, so validated data and, weather data, all of those things are a really important aspect of a safe aviation operation. And actually, we're quite lucky again, being part of, supported by the Boeing company. Boeing has, some other capabilities in this area. So we are working with other Boeing companies to, identify how will the system come together, how can we support that robust data. And, that'll be communicated to aircraft during the flight and, just support this general situational understanding.
Cool. Now, walk us through the testing. There's been years and years of testing. You're at your 6th generation. You've flown in New Zealand, I don't know, hundreds of times or a whole bunch of times, maybe in total thousands of flights. What can you share in terms of that and where you are in that sort of testing journey, because the conversations are sort of starting to go beyond the fact that you can fly and you can fly quite successfully. You seem to be getting closer and closer to sort of important commercial realities now, right?
Yeah, it does. It is exciting to be moving in that direction. So Wisk has in excess of 1,600 total test flights across 5 generations of aircraft. So that's a huge amount of experience around our systems, our batteries, propellers, motors, how we communicate, all of those really important aspects of our aircraft. We're now developing preparing for the certification of our Generation 6 aircraft, the aircraft that will come to market this decade. And so we're working with the Federal Aviation Authority on our certification process for that aircraft. And what that certification will involve is a huge amount of testing, right through from component testing, which is already underway, to testing our electronic systems, our avionics, our airframe, flight testing our communications, our precision navigation systems, how our operators work. So there's a whole sort of journey of operational validation and certification testing that we are moving towards at the moment. And that's where we will start collecting the specific evidence that supports our safety case and our certification process. So that'll be a really important part of showing the regulator and showing the community that we're safe ahead of our operations.
When do people fly? When do you start putting people up in the air?
We get that question a lot, actually. One of the most common questions is, when can I go flying in one? We've got a lot of excited customers out there. So there's a couple of things to say there. Firstly is that we work closely with the regulators, because ultimately the regulators will determine the timeline. We need to have our aircraft, our production systems and our operations certified, and we won't be flying until we're certified as safe by the Federal Aviation Authority and regulators in any other countries, such as the Civil Aviation Authority in New Zealand. That's really, really important. But with that in mind, we do expect to be flying this decade. We have a plan in place. We have the staff. We have the work underway with the FAA. So it's really exciting to think that we're not all that far away when you think about it from this being part of our transport landscape.
And so at this point in time, all the testing you've done is sort of fully autonomous with no people in an aircraft. What can you share on that?
So we did some testing initially. So we've had 5 generations of aircraft. And in our first few generations, we did have a pilot on board as we tested those initial things like the transition from vertical to horizontal flight. But since 2017, we've been operating without a pilot on board. So we've been operating completely controlled by our staff on the ground from our ground control stations. So we've got a lot of experience in
right.
autonomous operations.
So do you test with staff inside from a passenger perspective at this point, or you don't need to? There's no benefit? What if you've done that early on? Obviously they were the pilots, but now? Does that sort of wait until you get to a next level of certification?
Yes, so we are currently not flying passengers in our aircraft. It's really important that when we bring passengers on board or our own staff as in the passenger seats, that's in accordance with the appropriate approvals from the FAA, and that's really important to us to demonstrate that commitment to safety.
What would you say are the biggest challenges that Wisk has got through to date? Because it's clearly not an easy journey. There's a lot of challenges to get through, and the last time I chatted with someone from Wisk, with previous CEO Fred Reid a few years ago, it sounded like the business had the team had already been through some pretty hard stuff at that point. I'm sure the last 5 years there must have been some pretty challenging technical things to work through and so on. Not to mention funding. Obviously Boeing's sort of part of the mix now as well, because it's not a cheap enterprise to get involved in, is it?
Yeah, that's a great question actually, and I'm not an engineer myself, but I sit in some of these conversations with our engineering leadership and our engineers, and I'm just blown away, with some of the things they've worked through. An early milestone for Wisk that we really view as a mark of maturity in the industry is the transition from vertical to horizontal flight, and that involves a huge amount of maturity in all of the systems. And of course, I mentioned, moving from piloted to autonomous. But to get to where we are, we've developed a battery that can conduct VTOL and horizontal flight. We've developed propellers. We've developed in-house our own motors to operate off the batteries. We've developed our autonomous systems. It's just extraordinary. I sometimes like to say that advanced e-mobility, it's not one innovation, but many. And in fact, we have, I think, in excess of 190 patents involved with our aircraft and innovations. That gives you a bit of an idea of the depth of innovation and hard work that's gone on for the whole team.
Yeah, that's a lot of patents. Suggests a lot of innovation in the background there. And so, in terms of size and sort of scale for Wisk now, can you talk to how many people are involved in Wisk around the world? Or
Yeah, so Wisk has been growing. We are now around 700 staff, which is really exciting. That includes a lot of staff from our supporters Boeing and Aurora Flight Sciences who are embedded with our teams, but we've got a team in California, our headquarters and our prototype manufacturing facility in Mountain View. We've got a test flight facility in Hollister. We've also got a team in Montreal, in Atlanta, in New Zealand, and now staff in Australia. So, very much a global and growing company. Mostly engineers and flight tests, but increasingly we've got staff in areas of certification, regulatory, business, passenger services. As you can imagine, when you go to change the world, you need a good team.
Yeah, that's great. And looking to New Zealand, obviously you're based Wellington, and in a role that looks right across the region. But you've got other team members here in New Zealand. What sort of things are you doing in New Zealand now? Because the flight sort of testing isn't active in New Zealand at this point. That side sort of finished up for, at least for now, I take it.
Yes, so we've got a couple of work streams underway in this part of the world. First is our work with the Airspace Integration Trials Program, and headed up by MB, that CA and Airways also work closely with. So that's really exciting. And we also actually have some staff members working on battery technology right here in Christchurch,
cool.
which is really cool to see those opportunities for engineers to be involved in an industry like this. And we also are working closely with regulators and governments, and also with city planners, as we think ahead to what it will take to integrate our aircraft into cities in the future. There's quite a bit of work there. So a few things going on.
Yeah, I can imagine on the battery front, certainly some challenges in terms of it getting a bit cold up there, and different challenges in terms of an electric vehicle that are maybe haven't been perfectly addressed by existing technologies.
Yeah, so batteries are a huge part of our innovation. And, the reason for that is they're part of the range of technologies that will help aviation decarbonise. And it's so important, especially for a country like New Zealand, that we have this future where we're able to connect with each other through air travel, but also that people, can have sustainable journeys. And that's one of the goals in the Aotearoa New Zealand aerospace strategy, building those sustainable journeys. So batteries alongside other technologies are part of that mix, but it does mean we need to work on a couple of things. We need to, work on the density, the power density. It's really important that we have a high standard of safety. So we're working already with the Federal Aviation Authority on the safety of those batteries, and also, looking at the sustainability, like the full life cycle of how we handle and use them throughout life.
That's great. Anything else you wanted to add to the conversation?
No, a point I love to finish on is thinking towards the future of the aerospace sector. There's so many challenges and opportunities ahead of us, and it's so encouraging to see when we engage with the universities. We've got University of Canterbury right here. Auckland is really focused on this as well. That it's those students currently studying aerospace and mechatronics and all those contributing technologies that will help us solve those big problems of the future. So I'm really excited to see people continue to engage in the sector, to think about different kinds of futures and how they will contribute to safe and sustainable futures.
And how do you think, that we best let students know that there's opportunities in aerospace and in some of these advanced areas that New Zealand probably hasn't been known for historically?
A lot of talking. So that's one of the reasons I'm talking to you. I do hope there are some students out there listening. It's also why we're here at Te Pai at the Aerospace Summit and at the Innovation Expo, displaying our Generation 5 prototype aircraft that, actually flew at Tekapo, and talking to as many students as we can. We actually sponsored a few students here this week because we just want to open their mind as to the way that, the sector is changing, the opportunities are changing, and, we don't have the answers, they have the answers to a large degree. So, to get them thinking about the future challenges and how they're going to contribute. And one of the most exciting things when you engage with young engineers, those in the workforce and coming into the workforce, is how much they want to contribute to a sustainable future and how they want to combine, their technological background with that drive for sustainability and connection. So, every time we engage with young people and, people entering the sector, we're just so inspired, that it's in good hands.
Yep, that's great. Well, thank you very much, Catherine McGowan. Very fascinating to hear about what Wisk is doing. One last question: New Zealand-Australia rivalry. You're operating in both New Zealand and Australia. What do you think New Zealand needs to do to attract sort of more investment into our aerospace sector versus maybe what Australia or other countries are doing? How do we stay competitive so we attract as much action, activity and investment locally?
I'm glad your question wasn't about the Rugby World Cup, because I'm not really up on that situation. But I think it's not a zero-sum game. I think Australia and New Zealand are really complementary in how they can lift up the future aerospace sector. And I think where New Zealand can look to is that ability to bring the stakeholder group around the table and to solve system level problems. When you're thinking about how can we design airspace in the future so that it is more safe, how can we support these innovations, it's not a problem that you solve with maths, it's a problem that you solve with systems thinking. To go right back to that sort of Ernest Rutherford, we don't have a lot of money, so we have to think. So we can help solve some of these tricky problems. We can come up with innovative ways of looking at the future, and we can test and develop those, and then we can share them outwards with the world. And so we do have to acknowledge that technologies will be developed here, that at times then will be scaled globally, and that's okay, because then other companies who are looking to develop that initial stage and how can I weave my technology into a sector, they say New Zealand is somewhere, and is somewhere that I can go to figure that out so that I can make myself more marketable globally. And Australia, similarly, a slightly larger market, but again, in the same way that Australia helped small US become a commercial proposition. They're looking at how they can modernise their airspace system. So, I think we can both win.
That's good. Great to hear. All right. Thank you very much, Catherine.
Thank you, Paul. Lovely to chat.
Cheers.
The New Zealand Tech Podcast, brought to you by Gorilla Technology, proactive and strategic IT.